Trigonometry and physics. In this class, we'll be using some very basic trigonometric functions. Specifically, when you're dealing with a right triangle, we will often use the Pythagorean theorem and the simple trig functions sine, cosine, and tangent. Recall that a right triangle is any triangle that has a 90-degree angle in it. In the triangle pictured here, the right triangle is in the bottom right corner and is usually indicated with a little square in that corner. Traditionally, this angle is labeled as capital C. The side across from angle C is designated with a lowercase letter, little c. This side is called the hypotenuse of the triangle, and it's always the largest side. The designation of angle A and angle B is arbitrary. So it doesn't matter whether we call this angle A or whether we call the upper angle angle A. It simply depends on the problem you're working on as to how you label it for convenience. Let me label this particular triangle with angle A at the bottom left, B at the top. So then the sides across from these angles would be designated little a and little b accordingly. The Pythagorean theorem states that the square of the hypotenuse is equal to the sum of the squares of the other two sides. Usually in physics problems, we're solving for the hypotenuse, or side C. So you should remember the equation as C is equal to the square root of a squared plus b squared. It's important to remember that Pythagorean theorem can only be used when we're dealing with a right triangle. The other trig functions that are very useful for right triangle would be the sine, cosine, and tangent functions. So let's take a look at those. Again, we need a right triangle. All right. Now, I'll label my angles again. All right. And let me make some room here. Move everything over. The definition of the sine of angle A, and we'll use A here only as an example. Many times in physics, the angle that we want to work with would be designated by the Greek letter theta. But in our example, we will use angle A. The sine of angle A is equal to the length of the opposite side divided by the hypotenuse. Or, in this case, A over C. For the cosine function, cosine of angle A is defined as the adjacent side divided by the hypotenuse. And the adjacent side to angle A is that side which is right next to angle A. It would be side B. So the cosine of angle A is what you get when you divide the length of side B by the length of the hypotenuse. For the tangent function, the tangent of angle A is defined as opposite over adjacent. our example here, tangent of A could be calculated by dividing little a divided by side B. Students often memorize these definitions with the same SOHCAHTOA. The sine is equal to the opposite side divided by the hypotenuse. Cosine is equal to the adjacent side divided by the hypotenuse. Tangent is equal to the opposite side divided by the adjacent. What if we knew the value of two sides of this triangle, maybe side A and side B, and we would like to find out what is the measure of angle A? How large is angle A? Well, when you're looking for angles, you can use the inverse function of these trig functions, or arc sine, arc cosine, or arc tangent. So let's look at an example where we're trying to find an angle. So here's our triangle again, and let's imagine now angle A is the angle we're trying to find, and we know that the length of side A is equal to maybe 8. So A equals 8. And perhaps side B is equal to 3.5. Now, I'm not measuring this to scale. I'm just labeling these with lengths that I've imagined, just for the purpose of illustration. But if the sides actually had lengths 8 and 3.5, and I were looking for angle A, then I could use the tangent function. We know the length of the opposite side, and we know the length of the adjacent side. So to find angle A, use tangent. Tangent equals opposite over adjacent. So 8 divided by 3.5. Then angle A can be obtained by taking the inverse tangent of both sides. Or angle A is equal to inverse tangent of 8 divided by 3.5. And of course, 8 divided by 3.5 is just a number. Let's find out what it is. Now, different calculators allow you to either enter an entire expression as a formula, or you might have an older calculator similar to this one, where we must first calculate 8 divided by 3.5 before taking the inverse tangent. 8 divided by 3.5 gives us 2.2857. So if we take the inverse tangent of that number, it will tell us the measure of the angle. Inverse tangent. It is a 66.4 degree angle. Remember, your calculator must always be in degree mode when using these trig functions. Lastly, if you're dealing with a non-right triangle, in that case, we must use law of cosines and law of sines. The law of cosine says that side C is equal to the square root of a squared plus b squared minus 2 times a times b times the cosine of angle C. And our law of sines says that the sine of angle A divided by the length of side A must equal the sine of angle B divided by the length of side B, which must also equal the sine of angle C divided by the length of side C. We will use only 2 out of the 3 terms here, depending on what information is given in our problem. For example, if we know how large angle C equals, if we know the size of angle A or of side A, then we could use this information to find the length of side C. Or, typically in physics, we'll be looking for an angle. So that knowing at least 2 sides and 1 angle, maybe side C, angle C, and side A, we would be able to find the measure of angle A. So we would not need the middle term in this expression. It would simply drop out.